Welcome to Gopher Security. Today we're going to show you how Gopher delivers quantum-safe hosting for AI infrastructure. We're going to talk about containers running your LLMs, your MCP servers, your AI agents, and the actual compute layer underneath everything. We're going to walk you through the full security configurations, creating policies, defining what each user can and can't do, and attach those policies so zero trust is enforced from the moment someone joins the network. To kick things off, here's the situation. When you're deploying AI infrastructure, LLMs, MCP servers, AI agents, you're running them on containers. Kubernetes is orchestrating those containers across multiple virtual machines and servers. And you have Kubernetes control plane that's talking to worker nodes. Containers are spinning up and down across different VMs, and there's control traffic flowing between all of these different pieces. And that traffic is your attack surface. So if an attacker gets into that control plane, they can steal the data, spin up malicious containers, move laterally across your entire AI infrastructure, and traditional container security doesn't address this well. Network policies are underutilized, encryption between nodes is often missing, or uses algorithms that quantum computers will break. Solve this by privatizing all control traffic between your container environments using quantum-resistant end-to-end encrypted peer-to-peer tunnels. And then we layer granular policy control on top. Even the people with network access can only do what they're explicitly authorized to do. Let's take a look at this network diagram here, and let's walk through the architecture. So these blue boxes are your virtual machines, your servers on the Kubernetes control plane. And the others, you have container workloads, your MCP servers, your LLM endpoints, and your runtimes. These red and purple lines, that's the Gopher network. Every machine gets assigned a Gopher private IP. These are peer-to-peer, end-to-end encrypted tunnels, quantum-resistant encryption using Crystal's Kyber for key encapsulation, and Falcon digital signatures with quantum resistance baked in. This is how we protect your control traffic. Kubernetes controller talking to container nodes talking to each other, and all the communication is locked down inside of Gopher's private mesh. It's privatized, encrypted, and zero trust is enforced. With data traffic coming in from the internet into your MCP servers, users and AI agents hitting your endpoints, the MCP request is what MCP gateway secures. Unified authorization, granular policy controls, full observability, and quantum safe infrastructure underneath, MCP gateways on top for full stack AI security. Now we'll discuss universal connectivity and high availability. Because this is a peer-to-peer mesh network, your servers don't have to be in the same cloud. They don't even have to be in the same country. The servers could be on AWS, on Azure, one could be on the home lab machine, someone's on-premise data center. Gopher assigns a private IP to each one, creates an encrypted tunnel, interconnects everything with no VPNs, no network redesign. Just install the Gopher app and they're part of the mesh, which creates high availability, every tunnel, every connection, post-quantum encrypted, so even state-backed actors doing harvest now, decrypt later attacks are unsuccessful. All right, so let's go and build this live. As you can see here, I'm in the Gopher dashboard, and first I'll create our secure AI infrastructure network. Let's navigate to the network section here and create a brand new network. I'll name this LLM Infrastructure Secure AI Network. And to give it a good description, which will be security for AI. And we'll create this network here. This network will be the private overlay connecting all the machines running our AI workloads, the Kubernetes control plane, the container nodes hosting MCP servers, and the LLM inference endpoints. So the network is created. Now I need to add machines to it. So for this, back in our dashboard, we'll go ahead and create a group for our MCP server nodes in Azure. So let's go ahead and name this group MCP server nodes for Azure. And we'll assign the email to myself and create this new group. Now we'll also need human operators. Let's move over and we'll create operators who manage this infrastructure. For this example, we'll add a SOC analyst and a security admin. Now we navigate to the user menu here, go to the user section and create a new user. We'll name our SOC analyst James Casey, and we'll go ahead and select James Gopher.security email and enable MFA. Now we have our new user, James. For our second user, I'll fill in information for myself, assign my work email, and enable MFA as well, and create the new user, Alan. Now that we created the groups and the human identities, they're connected through the Gopher quantum safe tunnels, but just being on a network doesn't mean that you could do anything you want. That's where the policies come in. Why policies matter? This is the zero trust piece that a lot of network products skip. They give you encrypted tunnels, they give you a mesh, but everyone on the mesh has the same level of access. That's just private network. With zero trust, it means that every user machine only gets the exact permissions they need and nothing more. Policies enforce permissions on resources using a set of actions. You create the policy, then attach the users, groups, or networks. I'm going to create two policies with different privilege access and attach them to the new users we just created. Now that we're back in our dashboard, we'll navigate to the policy section here, and we'll create a new policy. So our first policy that we'll create will be for James, our SOC analyst, where we'll provide him with read-only policy. So we'll go ahead and type in read-only policy level 2. Description will be read-only access for monitoring and observing AI infra. This will be for users who need visibility but shouldn't be making any specific changes. Think of our SOC analyst, compliance auditor, anyone who needs to see what's happening without touching anything. So we'll select the policy type, which will be API, and then select read with full read access. And then select the resources that this would apply to, and click Create Policy. Now we have our AI Infra Read-Only Level 2 policy. Once we navigate to the policy usage, we could attach the entities that we want access to this policy. We'll select James and attach this policy to James's account. Now we have attached the read-only policy to James, who will now have the full ability to read data, but no write, no remove, or delete access to the API. Now let's move on to creating the admin policy. We'll create a new policy, and we'll name it AI Infra Admin, full admin access for the AI Infra. We'll provide organizational access, and select all list, read, and write organizational actions allowed for this policy with access to all resources. And we'll create this new policy. Now we see that my policy is attached to my account with full read, list, and write permissions. And this is the smallest group where your infrastructure owners can do everything: manage users, create and modify policies, control the entire network, and manage all resources. Now that our SOC analysts have the policies attached to their accounts, they can monitor tunnel health, view connected machines, check network statuses, but they cannot deploy containers, modify configurations, or change security settings. This is what least privilege looks like in practice. When it comes to the admin policy, which I attach to myself, with this policy I have full control over the network, users, policies, resources, but the important thing is this access is explicit, not implicit. I didn't get admin access just because I created the network. I got it because a policy was created and deliberately attached to my account. Everything is auditable. And you can answer the question, who has access to what and why at any time in one place. Now let's take a look at how the Gopher app runs. Now when we open the Gopher app, we see the different networks we've created, and we also see our new LLM infrastructure secure AI network with the different users attached to this network that can access the specific resources within it. We simply click connect in the app, and we see that the connection is established. It shows that the quantum connection is secure for the entire LLM infrastructure, and I can access these machines directly with a peer-to-peer connection. Since I have admin level policy, my account will provide full access with all read, list, and write rules. So now let's zoom out and we'll take a look at what we've just built. We've built quantum safe hosting environments for our AI infrastructure, control traffic with privatized multi-cloud and granular policy controls enforced to control who can do what and what they could access. On top of that, we also deployed the MCP gateway. When the data traffic comes into the AI agent making MCP requests, the gateway handles unified authorization, granular policy controls, and full traceability. Every tool call is authenticated, authorized, and logged. So your MCP servers are deployed as containers on the infrastructure. The containers talk to each other through the Gopher quantum tunnels and enforce policies. The agent requests coming into the MCP servers go through the Gopher MCP gateway. Infrastructure security, application security, unified in one platform. Now let's quickly recap what we've built and what we covered. So first of all, we designed a quantum safe control traffic for all communication between your Kubernetes control plane and coordinated nodes, which are post-quantum encrypted, where harvest now, decrypt later attacks are neutralized. Second, we designed universal connectivity for our AI infrastructure, spanning AWS, Azure, on-prem, and any combination of the three. Peer-to-peer mesh networking, all done in one click. Third, we designed granular policy enforcement, 3 distinct policies, a read-only, operator, admin, each scope to specific services, actions, and resources, and attach specific users with least privilege access from the start. Fourth, we deployed real AI zero trust. Being on a network doesn't give you access, but policies do. Every action is authorized, every authorization is auditable, and comes with high availability, multi-cloud, multi-vendor, with no single point of failure. Full stack AI security with quantum safe hosting underneath, MCP gateways on top, and policies at every layer on one platform. If you're running your AI infrastructure, MCP servers, deployments, agent frameworks, your hosting environments need to be secured at the network level with proper access controls, not just VPNs, not just encryption, real policies, real zero trust, and real quantum safety. So Gopher gives you all of that. Book a call with us at gopher.security. We'll run a free zero trust MCP assessment for your environment and show you exactly what your risk surface looks like. Thank you for watching. See you in the next one.